Okay, this is the review session for Unit 3, Sections 3.1 to 3.4 test, basically on triangle congruence. So a couple things first. What are the 5 reasons you could prove one triangle is congruent to another triangle? Give me one. SSS. Give me another one. SAS. Give me another one. Good? Okay. So those 4 are the first 4 that we learned. Those 4, all the A's stand for angle, all the S's stand for side, and the order matches how things are marked in the triangles that you're talking about, right? So, okay. So, when you're deciding which postulate to use, you have to look at how things are marked in the diagram. It doesn't matter the order of anything else, like what comes first in the givens. What matters is how it's marked in the diagram, right? So if you have this marked congruent to that, and this marked congruent to that, and this marked congruent to that, then which postulate would it be? Side, angle, side, because the angle right here is wedged between the two sides that you have marked. So S, S, two sides, and the angle is actually in between the two sides, touching both sides. That's SAS. But if you have something like this, first of all, there's something else I could mark in this diagram that isn't marked yet. What else could I mark? Reflexive property right here. Whenever two triangles are stuck together and they share a side, you want to make sure you're marking that side that they share and use reflexive property. Okay, at this point you want to cover up one triangle at a time. I have no way of doing that on the video, but one triangle at a time. Which postulate are we going to use for this one? Yeah, Vincent. ASA, because in this triangle, you want to look at one at a time, right? You've got angle, side, angle, right? So this one is going to be ASA. All right, what if I have okay, in this type of a triangle, again, there's something else. We're just working on a blank piece of paper right now, so why don't you just grab. We need a space to write it down. There's blank paper right there. Okay, so there's another thing I could mark in this diagram. Kevin, what do you think? Vertical angles, very good. So we're going to mark this congruent to this by vertical angles. That's reflexive. These are vertical angles, right? Those are the two things that most commonly you're going to be able to mark on your own. Make sure that you, when you get your test, you kind of go through and you look for anything that's reflexive and mark it. Anything that's vertical angles and mark it. Those are the two things you really want to look for. Proofs, not proofs, whatever. Any diagram, you want to mark your reflexive and your vertical angles. Okay, so once I mark vertical angles, which postulate, again, kind of cover up one triangle at a time, and which postulate could we use here? It's going to be AAS, yes. AAS, because we have two angles marked, A and A. And now the side is actually not between the two angles. This side is touching one of these angles, but it's not touching both of the angles. So it has to be AAS. AAS. Okay, so the last one is just an example of ASA. So let's look at that. ASA would be if you have two, we did ASA? Oh, you're right. What did I miss? SSS. Oh, well, that one's easy. Okay, thank you. That would be just 3 sides to 3 sides. That would be SSS. Okay, so the two combinations that we said don't work, right? Big old X through SSA and AAA. They do not work, right? SSA or ASS, we said is a bad word, forwards and backwards, right? AAA is a travel agency, not a postulate, right? So those two don't work. Those do not help you to prove triangles congruent. There is one more postulate that does work, has a different name, looks a little different. What's that one called? Like HL, right? So HL is our last postulate. It's a little bit in its own category. And what kind of triangles do we use HL with? Right triangles, right. Right triangles only. Okay, so you're going to have one triangle to another triangle. There has to be right angles in it. H stands for hypotenuse, so the side across from the right angle has to be marked congruent to the side across from the right angle. That's what hypotenuse means. Hypotenuse congruent to hypotenuse. Okay? And then leg congruent to leg. That would be HL. Remember that this is a special case of SSS. It's SSA. It's SSA with a right angle. SSA with a right angle works, and we call it HL. Okay, so with the first 4 postulates that we talked about, when you're writing a proof, you're going to have 3 congruent statements. Right? Either an S, an S, and an S, or an S, and an A, and an S, whatever. 3 congruent statements. But with HL, how many congruent statements do we have? 2. An H to an H and an L to an L. 2 congruent statements. Plus right triangles. Okay, so we'll do a proof like that so you'll see what I mean. Okay, so for this video I want to do 2 proofs, and then I'm going to turn off the video and I'll answer whatever questions you guys have. Okay, so we're going to do 2 proofs on the video. Okay for me to go to the next? Alright, so I want you guys to write this down and try it yourself. Oops. Okay, so steps for solving a proof or writing a proof. First, what's the first thing we should do? Yep, mark the diagram. Now, there's two things that you mark the diagram with. Givens and anything else that you know, right? So that might mean reflexive or vertical angles, parallel. Okay, there might be any of those things that you already know. So givens and then other things that you can mark just based on your knowledge. So do that first. Everybody mark your diagrams with the given information. Okay, before you start writing the proof, mark your diagrams with the given information. Just mark. Don't start writing the proof yet. That's good. Okay, so mark it with the givens, and then mark anything else that you know. So there's a few things that we just know because we know geometry now. One of them is reflexive if they share a side, and the other one is vertical. Good. So this one has vertical angles in it. Don't mark what you're trying to prove. Okay? That brings up a good point, guys. Don't mark A congruent to E. That's not a given. That's what you're trying to prove. Do not mark what you're trying to prove. That will confuse you when you're trying to figure out which postulate to use. So only mark your givens and then other things that you know just from your geometry knowledge. All right. Okay, now the key is we are looking to use one of the postulates we mentioned, SSS, SAS, etc., to prove the triangle's congruent. We said we either need 3 congruences or we need 2 congruences and right angles. Those are our choices here. So the next thing we want to do here is decide which postulate to use. That's really the next thing you want to do. Before you start writing, notice I didn't start writing a proof yet. Decide what postulate you want to use because that's going to determine what your steps look like. So I think I walked around and saw everybody. If C is the midpoint of AE, then that means this is congruent to this. And if C is the midpoint of BD, that means this is congruent to this. I think everybody had that. And then the other piece of information that we know is the marking of the vertical angles. So all of your diagrams should look like this. Now we should be able to decide which postulate we're going to use. Which postulate are we going to use? Justin? Nope. How many? Look at one triangle at a time. Look at one triangle at a time, right? How many? Oh, you're looking at a different, okay, so how many sides do we have marked? How many angles do we have marked? So now decide where is that angle, right? We have 2 sides and 1 angle. So now decide, is the angle between the 2 sides or not between the 2 sides? What do you think? It is between. So which postulate is it going to be? Which postulate? What do you guys think? Side, angle, side. Because it's 2 sides and the angle between them. 2 sides and the angle between them. So S and S with an A in between. Right? So we're going to use SAS. So you might want to just jot to the side, you know, which postulate you think you're going to be using. And then we have to figure out how we're going to get those congruent statements going. Okay, so take each given. Now you can start writing the proof. Write each given separately. Oops. And then, okay, then you want to take each given and say, why are they telling me this? Why are they telling me that C is the midpoint of AE? What do they want me to say is congruent to what? So if C is the midpoint of AE, then I can say what's congruent to what? What would be my statement here? Yep. Good. And that reason would be definition of midpoint. So we're going to do something similar here. BC congruent to DC. And then since we, oh, okay. Did you have other questions I didn't get to answer for you? Okay. Are you sure? Okay. All right. Well, I will be here tomorrow morning at 7 a.m. I have people who asked me to come. So if you have questions or if you want to email me or whatever, just let me know. Okay. Yep. Put it with my coat so I don't forget it. Just put it with my coat. So are you going to your game? Okay. Are you sure you should be going to your game? Okay. All right, I see people need to leave and stuff. Should I just stop this and answer your individual questions, or is this good? Should I keep going? Tell me what to do. I'm here for you. I'll finish this one fast, okay? All right. Oh, okay, so then since we marked vertical angles congruent, we want to make sure we make that a statement. ACB is congruent to ECB. Oh, see, now I'm trying to hurry and I'm going to mess it up. That's an angle. That's vertical angle theorem. Now we've got our three congruences. We can point them all three to a statement that says triangle ACB congruent to triangle ECB, ECB, and we said we were going to use SAS. Now, once we know those triangles are congruent, we can move on to what we're trying to prove. Angle A is congruent to angle E, and that's by CPCTC, or definition of congruent triangles. Okay, what? You got it right. Good. Yay. Okay, so the only other thing I wanted to do as an example, I know time is ticking here, but is an HL proof. So if we have something that says given BD is perpendicular to AC and AB is congruent to CB, prove, let's just prove the triangle's congruent, that ADB is congruent to triangle CDB. Okay, so again, we follow our steps. We're going to mark our diagram, so I put the right angle there because of perpendicular. Let's put a right angle on both sides. AB is congruent to CB, we mark that. Remember, then mark anything else that you know. So what else would you be able to mark here? Yep, reflexive, you can mark this. Now, what postulate are we going to use? I kind of gave away that mystery, but yeah, HL, right? We have a right triangle two right triangles. We have the hypotenuse congruent to the hypotenuse. Remember, the hypotenuse is the side across from the right angle. And then reflexive gave us a leg to a leg. So this is going to be HL. So this proof needs how many congruent statements? HL uses how many congruent statements? 2. One for H, one for L. What's that third thing have to be then? The third statement has to say what? That they're right triangles. I said this a bunch of times in class. We did it a bunch of times, and then I gave that formative, and 65% of the people got it wrong. So you gotta really pay attention when you're using HL, that you make sure that you get that third statement correct, okay? So AB congruent to CB, that gives us our H's, right? H hypotenuse to hypotenuse. We made a reflexive BD congruent to BD. That gives us our leg to leg, right? That's the other side. So leg to leg. So it's this perpendicular that's going to give us the third statement, but we can't go straight to saying the right triangles. First, we have to say angle BDC and angle BDA are right angles. How did we know to mark those right angles? What was our clue? What word was the clue? Yeah, perpendicular. So the reason for this statement is definition of perpendicular. Still not ready. And this is the piece that everybody seemed to miss. Now we have to actually state that these two triangles are right triangles. Triangle ADB and triangle CDB are right triangles. What's the reason? Definition of right triangles. All right, now we got it. We have H to H, we have L to L, we have a statement that says they're right triangles. Now we can use HL with these three things and say triangle ADB is congruent to triangle CDB.